Good morning. Today we are starting with session 5, probability distribution. And I know we are familiar with this topic. Okay, we are saying session overview. Probability distributions are used to model problems involving uncertainties. For instance, how do you plan this year towards meeting next year's electricity demand, knowing that electricity demand next year is uncertain? So we use probability distribution where, like in uncertain cases, like chances, where you have chances like things occurring, events occurring and not occurring. You get it? All right, let's move on. So these are our session goals. At the end of this session, you should be able to understand random variables and probability distribution. We know this from last semester, business mathematics. The concept of random variables, discrete and continuous probability distribution. So under discrete distributions, we are going to learn 3 theories. That is the binomial distribution, Poisson distribution, and hypergeometric distribution. All right, so our main focus is on these 3 theories: binomial distribution, Poisson, and hypergeometric. All right, so these are our reading lists. Okay, all right, so a probability is a number between 0 and 1 that measures the likelihood or chance of an event occurring. So probability is between 0 and 1. All probabilities are greater than 0 and less than 1. So they are between 0 and 1. You don't have probability greater than 1. So the second point is an event with probability 0 means that event cannot occur at all, whereas an event with probability 1 is certain to occur, right? So let's say this Chelsea and Real Madrid stars. Real Madrid won 3-1 in the first leg. So the chance of Chelsea qualifying is low. You get it? So it's closer to 1. So it's certain to occur. It's certain to occur that Chelsea will not qualify. You get it? And an event, the third point is an event with probability greater than 0 and less than 1 involves uncertainty. You are not sure of it. You get it? And the closer its probability is to 1, the more likely it is to occur. So when that event is closer to 1, then it means it is more likely to occur. Because Real Madrid won 3-1, there's no, like, the likelihood of Real Madrid qualifying to the next stage is closer to 1. It's very, very high. You get it? And probability of Chelsea qualifying to another stage is very low. You get it? So when it's greater than 0 and less than 1, it involves what? Uncertainty. When it is 0, it means it cannot occur. When it is 1, it means it will surely occur. All right. Let's move on. So this one is a review. That's why I'm moving fast. Now, what's an experiment? So we are saying that. Can you all hear me? Can you all hear me?
Yes, please.
Okay. All right. So experiment is a process of obtaining outcomes for uncertain events. An experiment will produce exactly one outcome. So we are saying that experiment will surely produce only one outcome. You get it? So when you write exams like this, it's an experiment, and the possible outcome is only one. So it's A to F. So you get one of them. One course you not get A, and the same course you get B plus or C in the same semester. You get it? So it's like the result is only one. Possible result is only one. And the sample space is the set of all possible outcomes of an experiment. So let's say an example like this. the sample space of the exams is what? A to F. So because that's the possible outcomes. The possible outcomes are A to F. A, B plus B, C plus C, D, D plus E, and F. These are the possible outcomes. So that's the sample space. So in probability, the samples, the set of all possible outcomes is assumed known. You get it? Because we know that it's either you get A, B, B plus up to F. You get it? So it's assumed known. You get it? So the sample space in probability, the sample space or a set of possible outcomes is assumed known. You get it? So that one, you are just like you are aware of the results, but you don't know the exact results you are going to get. You get it? You know, after writing the exams, you can get A to F, but I don't know whether you are going to get A, B plus, C plus or so. You get it? That's the sample space as well. So when a coin is tossed 3 times, the sample space consisting of all possible events or outcomes is X. So when you toss a coin 3 times, now when you toss it once, you know that the sample space is head and what? Tail. When you toss it once or when you throw a coin once, it's either you get the head or the tail. But when you throw it 3 times, the sample space is either you get head, head, head in all of them, head, head, tail, head, and so on and so forth. You get it? So head, tail, tail, head, tail, head, tail, head, and you get all of them as what? To be tails. You get it? All right. Events. You're saying that this is any subset of the sample space. So tossing a die, the sample space is what? You can get 1, you can get 2, 3, 4, 5, or 6. But the event is what? We are saying event E246 is an event of obtaining an even number. You get it? So the event is within the sample space. You get it? So the sample space is the possible outcome of tossing a die or throwing a die once. It's either you get 1, 2, 3, 4, 5, or 6. And the event is what? A subset within the sample space. So even number within the sample space, when you throw a die once, is 2, 4, and 6. Because we have 2 here, 4 here, 6 here. So the event is a subset in what? The sample space. You get it? So let's continue. Random variable X. So a random variable is a real valued function defined on a sample space. It assigns value to each of an experiment outcome. So the random variable simply means quantifying the possible outcomes. You get it? So when you write exams like this, you know that you are going to get A to what? F. But this random variables means you are placing or you are quantifying the results that you are going to get. You cannot use A, B plus, and C plus, those that we are placing numerical values on these possible outcomes. You get it? So we represent A by 1, B plus by 2, B to be 3, C plus to be 4, C to be 5, D plus to be 6, F to be 7. So random variable means placing or quantifying the possible outcomes. You get it? The sample space. You are placing numerical values. There's a 0, 1, 2, 3 on the sample space. You get it? So in 3 tosses of a coin, the number of heads obtained may be described by a random variable X as this. Let me move to a second example. What grade do you anticipate to earn in 301? UGBS 301, the quantity that we are doing. What's your aim? What's your goal? I mean, the results. So the possible outcomes is what? Grade A to F. But here we are saying that the random variable, we are just placing values, numerical values. We are quantifying the possible results or the sample space. So we represented A to be 1, B plus to be 2, B to be 3, C plus to be 4. So the random variable simply means placing numerical variables on what? The possible outcomes. You get it? Okay. So any question before I move on? So here they are saying that note that the original letter grades were changed to numbers. You get it? The grades were in alphabetical form, but we quantified it. So it changed from alphabet to what? Numbers. That's why we are seeing possible grades S, then random variable X representing possible grades are X is equal to 1 to 7. You get it? So we just change the alphabetical something to what? Numerical values. You get it? Any question before I move on to the types of random variables? Any question? Okay, let's make progress. All right, so we have two types of random variables. They are saying we have discrete and continuous variable. So a discrete random variable has only a finite number of possible values. Finite number of possible values. You get it? Finite number of possible values. And a continuous random variable has a continuum of what? Possible values. All right. So you will explain further in the next slides. Let's move on. So let's tackle the discrete random variables. So discrete random variables can only assume a countable number of values. I will use whole numbers because in discrete random variables we don't have something like fraction, decimals. No. It deals with the whole, like number 1, 2, 3, 4, 5. You don't deal with 15.2, 15.35, 1/2, 1/3. No. Discrete random variables can only assume a countable number of what? Values. So 1, 2, 3, 4, 5, and so on and so forth. Yes, it. So example 1, let the number of times a 4 comes up when a die is rolled twice. You get it? When you throw a die twice, you get it? The possible outcomes are 1 to what? 6. When you roll it once, when you throw a die once, the possible or the sample space is what? 1 to what? 6. But here they are saying that the discrete random variables of a 4, the number 4 on a die coming up twice is X is equal to what? It's either you don't get S at all, you don't get the number 4 at all when after throwing the die twice. You not get 4 in any of them. Or throwing it twice, you get only 1 4. Or throwing it twice, you get all of them to be what? The number 4. So that is your discrete random variable. Now note the discrete random variable, you always start with a 0 because there will be a probability. There can be a probability that you not like that event will not occur at all. Cannot occur at all. You get it? Because it's possible that you can roll a die twice. The first one, you not get the number 4. Second one, you not get the number 4. So the probability of it not occurring is there. So all the random variable, when you are starting, just start with 0. Now, when you roll it twice, you get it. The first one is either you not get 4. You get it. Second one, you not get 4. But you can get 4 in your first rolling. You get it. But the second rolling, you not get the number 4. Or you can get 4 in all of the 2 rulings. You get it? That is either the number 4 would not show up at all, as I said. When you roll it twice, in all of them, you not get what? The number 4. Or it will only appear once or appear in both rows. All right. Example 2. Let X be the number of heads obtained when a coin is tossed 4 times. Then a random variable or a random number of possible values. Mind you, I said when you are starting with the random variables, start with 0 because there can be a chance of that event not happening at all. You get it? So we are saying that when you like a coin is tossed 4 times, we know that when you toss it once, the possible outcome is what? Or the sample space is head and tail. But here we are seeing that when a coin is tossed 4 times, you get it. Then X is a number of possible values. You get it. So there can be the probability that probability that obtain head, you obtain only 1 head, you obtain 2 heads, you obtain 3 heads, or all of them you get what? 4 heads. You get it. So the 0 is very, very important. Don't just start from 1 because they are saying 4 times, so it's 1, 2, 3, 4. No, there can be a chance whereby you not get a head after tossing all the 4, like tossing it for 4 times. You get it. Or is either you're going to get 1 head, 2 heads, 3 heads, or what? All of them to be what? The head. All right, let's make progress. Discrete random variable example with. So we are considering the examples. You get it. So we are saying that example with many possible outcomes. So discrete random variables. So you can, the number of complaints per day, you can count them. There's no fraction, there's no decimal. It's 1, 2, 3, 4. Number of TVs in a household. You get it? In a household, you can count the number of TVs 1, 2, 3, 4. You cannot say 2.5 TVs. No, you don't have 2.5 TVs. If it is 2, 2. If it is 3, 3 TVs. You don't have 3.5 TVs. So the discrete random variables deals with the whole numbers, that like the one without the numbers without fraction and what? Decimal values. Number of cars passing between 7 a.m. and what? 9 a.m. You can count the number of cars. You will not get 200 and 200.5, 200.6. It's either 200, 205, 700, 300. So it deals with numbers without what? Fractions and what? Decimals. Number of rings before the phone is answered. You can count them as well. Example with only 2 possible outcomes. Examples with only 2 possible outcomes. And this is where our emphasis will be. The examples with 2 possible outcomes. This is where we are going to use the binomial distribution. So these are discrete random variables with only 2 possible outcomes. So in terms of gender, male or female, even these transgenders or something, I don't know, they are under one of these. You get it? It's either male or female. You cannot be both. You get it? Defective is yes or no. Game is either you win or you lose. All right. So this is where our emphasis will be. This is where we are going to use the binomial. The word by is 2. So example of discrete random variables with only 2 possible outcomes. All right, let's make progress. So let's read about the continuous random variables. We are saying that it's a variable that assumes any value on a continuum can assume an uncountable number of values. So this can potentially take on any value. The word any value. So being it fraction, decimal, or something, you can use the continuous random variables. So we are seeing the example is what? Thickness of an item, time required to complete a task, temperature of a solution, height in inches. So you can get what the height, you can get 156.8 centimeters, any value, you get it. And the discrete random variables deals with what? The numbers without, or the values without fraction and what? Decimals. So that's the difference. You get it. And let's move on. Now let's move to probability distribution. Now we are saying a probability distribution is a way of describing the uncertainty of some numerical outcome. The second point, probability distribution assigns a probability to each of the possible outcomes of a random experiment. You get it? So the probability distribution assigns probability to what? The random variables. So looking at the third point, it says it does nothing. more than a list of all random variables and their corresponding probabilities, usually presented in a graphical or tabular form. So the probability distribution is simply the random variables, which are the x's, x1, x2, x3, x4, and so on and so forth, and their corresponding probabilities. So x, the first x1, its probability can be 0.2, the second one can be 0.1, third one can be, probability can be this. So that table representing those relations is what is termed as what probability distribution. So example is you're given a random variable x, x1, x2, x3 to xn. The table below then is the probability distribution. Do you get it? So let's take a quick example here. The probability distribution of the number of heads in 3 tosses of a coin is described as shown below. Do you get it? Is anyone talking?
No.
All right. So you are seeing the probability distribution of the number of heads in 3 tosses of a coin is described as shown below. So as I said, the probability distribution is just a relation. Like it is a list of all the random variables. So the random variables are the x's here, the one on top, the 0, 1, 2, and 3. And their corresponding probability. So the 0, its probability is 1/8. 1, its probability is 3/8. 2, its probability is 3/8. 3, its probability is what? 1/8. And remind you, note, all probabilities are sum up or add up to what? 1, because probabilities is every probability is between 0 and 1. It cannot be more than what? 1, and it cannot be less than 0. So this one they worked it for us. So don't worry about the 1/8 and stuff. You get it? Just an example. Let's move to properties of probability distribution. So let x1, x2, and x3 to sm be m possible values of the random variable x. If probability x is equal to xi or pxi, probability of xi is the probability of the random variable taking on the value xi, then the following must hold. So all that we are saying is that all the probabilities are greater than or equal to 0 and less than 1 or equal to 1. So they are just telling us that probability, every probability is equal to 0 or greater than 0 and equals to 1. It can be less than or equal to 1, because all probabilities are between 0 and 1. You cannot be less than 0, you cannot be more than 1. So that's what they are illustrating with here. So greater than or equal to 0, it can be 0 or it can be greater than 0 or equal to 1. You cannot get 1.01 even as your probability. You know, when you get that, then you are lost. You get it. All right, let's make progress. So yeah, this is just a review. That's why I'm moving fast. Okay. When you get to binomial distribution, I'll take my time and explain things. Because this one we learned it, you can see it here. Review from UGBS 202. We learned it last semester. Okay, so let's move on to mean honest or expectation of what? A random variables. So a mean normally represented as this. This one is called mu, mu, mu. You get it? So a mu often offered to as expectation of a random variable x is denoted as E and S. Mu is equal to this and is equal to what? The random variables times your what? Probability. So the mean or expectation of a random variable or mean or expectation of a probability distribution is just your probability of a certain number, a certain random variable I times what? Their probability of a certain random variable times the random variable itself. You get it? Then if you are having more than one, you do sample that, like you multiply probability by the random variable, you add it to the another x that you're having. You get it? Good. So if you show workings, you will see it. All right. We are saying that some books use this. Okay, this one is the mean is a weighted sum of possible values weighted by their probabilities. The expectation of mean indicate the center of the probability distribution, much as an average of a set of numbers indicates our central location. So we all know what a mean is. So variance of a random variable too, we know how it is. That one to the probability multiplied by the random variables minus the so the variance is the probability of a random variable multiplied by a random variable itself minus what? The mean, then you square it. So when you're having two or more, you do a sum product. The answer will give you at your variance. Whereas we have like standard deviation. So after getting your variance, when you want to solve for the standard deviation, you just find the square root of your what? Variance. That will give you your SD, standard deviation. Okay, let's solve for this example. So we are saying demand for electricity next year is projected. So you are doing projection to one of the following quantities. One is 18,000, the unit, I don't know, something watts, with probability of what? 0.4. 25,000 with probability of what? 0.4. 30,000 watts with a probability of what? That one they didn't give the the 30,000 is what? They didn't give the probability for 30,000. They just gave the probability for 18,000. Probability for what? 25,000. So you just draw your tables. You are going to draw your part, the probability distribution, and we explained that probability distribution is just what? A table illustrating the relation between the random variables x and the what? Probability of the random variable. So this one, they will give us the random variables, they will give us the probability as well. So the first x they are saying is 18,000. Sorry for the handwriting. The second one is what? 25,000. The third one is what? 30,000. So this is a projection. So they're saying next year, this is a projection, 18,000, but this year's demand is this. So if you are projecting next year's own, you just subtract the 17,500 from all of these 25,000, 30,000, and what? 18,000. Because the 18,000, 30,000, 25,000 is here are your projections, and this is this year's own. So when you are calculating for the exact x, you just have to subtract the 75,000, which is this year's own, from what? The projection that you have made. Okay, so this one is going to this minus 17,500. I'm using mouse. Sorry. This one to 17,500. This one to 17,500. Sorry if you can't see. And they are saying the probability of 18,000 spawn is what? 0.4. The probability of what? 25,000 is what? 0.4 as well. But that of 30,000, they didn't give us probability. Who can tell me the probability of 30,000 and why? Who can tell me? Please, someone should answer this for us because we know.
I think it's
0.2.
Yeah.
Okay, so why?
because we say probability is equal to 1, and
Yeah.
we have 3 events. Let me say 3 events, something like that. So if 0.4 plus 0.4 it will be 0.8 minus 1, which if added to it will make it 1, which will make all the distance we want. That's what I think.
Okay, so we are saying that all probabilities add up to be what? 1. So if you're having 3 random variables, you're having 3 random variables with what? 3 probabilities, and they've given you 2 of them to be 0.4, 0.4. When you add them, it is what? 0.8. And we are not giving the last one. We know that all probabilities are added or sum up to be what? 1. So you just subtract the summation of the 2 given from the number 1. Then you get the third probability to be what? 0.2. Okay. Okay. Thank you, Roland and Roland and Artford. Thank you. All right. So we are saying, so this is the what? Probability distribution. So we are saying it's nothing more than a list of what? Random variables on top and their corresponding what? Probabilities. So that's just probability distribution. Now let's learn how to find the expectation, that's the mean, and how to find the variance and how to find the standard deviation. So we are saying your expectation or mean, you just multiply probability. So this probability multiplying this x. So the x, you subtract 75 times from 18 times, it's what? 500 plus this probability times the x here. When you subtract, you do the subtraction, you get 7 times 500 plus okay. So then this probability times the x here. This is 3 times 17 times 500. You get 12 times 500. And you do the sum product 0.4 times 500 plus 0.4 times 7 times 500 plus 0.2 times what? 12 times 500. You do the sum product, you are getting what? 5,700. So this is the mean or expectation. So your probability of that x times the x itself, summation of it will give you that. You get it. When you're having 2 or more, just do for each of them, you add, you multiply and add sum product. Okay, now let's move on to the variance. Now the variance to the formula is this. So you see that the variance, you just take the probabilities, multiply it with what? The x, you subtract mu from it, you square the difference, you multiply it with the probabilities, plus the same thing, you find a difference of what? You find a difference between the x and what? The mean or expectation. You square them, you square their difference, you multiply it with what? Their probability, plus you find the difference between the x and what? The mean or the mean. You square the difference, you multiply it with what? Your 0.2, that's the probability. Summation of it will give you what? The variance. And when you are working for the standard deviation, you just square your variance. So standard deviation is equal to what? Square root of what? Variance. Okay, the meeting is ending soon. Join with the same link, right? Then let's continue. Okay, so standard deviation, you just what? Square, you just put square root on top of your what? Variance. The answer is going to give you the standard deviation. All right, so this is just a review. We know about this. So I hope all of us understood it. All right, so let's move on. Let's make progress. So join with the same link. Okay, I'm ending it because it's ending now. Bye. So as I said, to get your standard deviation, you just put square root on top of what your variance, and that will give you that. That will give you a standard deviation. All right. Oh, okay. Okay. I'm coming. So we are moving to the binomial distribution. You get it? Because I said under discrete random variables, we are going to learn 3 theories. We have the binomial distribution, Poisson distribution, and what? Hypergeometric distribution. You get it? We are seeing the binomial distribution. So we are starting with the binomial distribution. The binomial distribution is used to describe a real world phenomena where an event results in what? Only 2 possible outcomes. So as the name depicts, by means what? 2, by means 2. So binomial distribution. So where an event results in what? Only 2 possible outcomes. So when you play a football match, it's either you win or lose. That's the probability you know. You get it. When you apply for a job, it's either you are offered that job or you are what? Like denied or disqualified or something. You get it. The same event is repeated multiple times. It describes the distribution of a success in n series of trials out of n series. What is the probability that x of them succeed? You get it. So success is what we'll be looking for in an application. Okay. So success is like our interest in a certain let's say application. Right. Let's make progress. You get the success. So examples: a manufacturing plant labels items as either defective or what? Acceptable. So a defective means faulty, something with fault, a product with fault or something, or an item with a fault. So it's either defective or acceptable. So it's either bad or what? Good. A firm bidding for a contract. So when a firm bids for a contract, it's either you get a contract or you don't get. That's the 2 possible outcomes. A marketing research firm receives a survey responses, yes, I'll buy, or no, I will not. New job applicants either accept the offer or reject the offer. You get it. When you propose to a lady to, is either you be accepted or you get bounced. You get it. So that's the 2 possible outcomes, right? So let's look at the characteristics of what? The binomial distributions. A trial has only 2 possible outcomes. Good. So before we can apply binomial distribution on a certain application or a certain question, make sure that application you are giving has only 2 possible outcomes. The word here is binomial. So we are looking for 2 possible outcomes. So success or failure, yes or no, win or lose, and those stuff. There is a phase number n of identical trials. So the n here is what? The sample space. The trials of the experiment are independent of what? Each other. The first trial has nothing to do with the second trial. So they are mutually exclusive. You get it? They are mutually exclusive. So the results of the first one has nothing to do with the result of the second event. You get it? So the probabilities of a success, P, remains constant from trial to trial. So in a binomial distribution, we represent the probability of a success. And I said the success is the interest of the question, you get it, or the interest of the application. So the probability of that success is represented as P. Whereas Q is the probability of failure, because if P is our heart, if P is our probability of success, then our probability of failure will be the probability of success, the 1 minus our probability of success, which will give us Q, because we know that all probabilities are added to become what? 1. And we know the probability of success. You just subtract it from 1, you get a probability of what? Failure. You get it? So that's the last point here. Let's move on. So any question on the binomial distribution? Do you have any question for me before we start with the example here? Any question with me? Any question for me? Sorry. Any question for me?
No question.
Oh, okay. So someone should read this one for me.
Okay. So household security produces and installs 300 custom-made home securities units every week. The units are priced to include 1-day installation service by 2 technicians. A unit with either a design or production problem must be modified on site and will require more than 1 day to install. Household Security has completed an extensive study of its design and manufacturing system. The information shows that if the company is operating at standard quality, 10% of the security units will have problems and will require more than 1 day to install. The binomial distribution applies to this situation because of the following conditions exist.
Okay, thanks, Senior. So we are saying that a household security produces and installs 3 custom-made home security units every week. So a unit with either a design or what production problem must be modified on site and require 1 day to install. Household Security has completed an extensive study of its design and manufacturing systems. The information shows that if the company is operating at a standard quality, 10% of the security units will have problems. In other ways, 10% will be what? Defective and require more than 1 day to install. The first question you have to ask yourself in any application question under binomial distribution is, does the problem given or the application given satisfy the binomial distribution rules? What you are saying, it must like you should have only 2 possible outcomes. Binomial, is 2. So you can have only 2 possible outcomes. So they are saying that when the company is operating at a standard quality, 10% of the security unit will be what? Defective or will have problems. Having problems here, in other words, is defective. And we learned in examples that it's either good or what? It's either acceptable. Acceptable is good. You get it? It's either good or what? Defective. Defective is bad. You get it? And this question too, you have to pinpoint or figure out your success. And the success, I explain it what? Our portion of interest. Now, the question didn't talk about what? The good or acceptable unit. It only talked about the unit that will be what? Defective, the unit that will have problems. And the question said that 10% of the unit will have problems and require 1 more day to install. First of all, the question here explains the reason why we can what? The statement here explains the reason why we can apply binomial distribution. And I would say yes, because it's 10% will have problems because the possible outcomes is either the unit will have problem or will not have a problem. So in other words, it's either acceptable or good. Acceptable, let me use the word good. So is that good or what? Defective? Defective or simply means it has problems. It has problems. Do you get it? goods or unit with what faulty like problems. It is having fault with it. You get it? So there's success here in this question is what? The defective, because the 10% mentioned was for defective unit, not for what? Good unit. Though the success is what? Like this positive things, but I mentioned that the success is our portion of interest. You get it? So where we are interested in. So this particular application, we are interested in the unit that will get problems, that will be defective. So the success is the defective problems. And the probability of a success, which is the P, is what? 10%. So who can tell me the success of the failure kill? The probability of the failure kill. Who can tell me? So 10% is what? 0.10 to get it. So if the probability of success or the probability of defective unit is 10, what will be the probability of what? Good unit or probability of what? Failure. Who can tell me?
It's 1 minus Q.
1 minus
0.1.
P. 1 minus P. So it's 1
Q,
minus.
is it Q or P?
Is it?
0 points. Okay.
Yes. So you get.
0.9.
Okay, someone was saying it's equal to Q. Come again. Now, per what I explained, I said the Q represents the probability of failure and the P represents probability of success. And in this particular question, I'm saying that our portion of interest is the portion of interest, or our interest in this particular application is what? The defective unit. So defective unit will become our success. So when you're able to figure out the defective unit, it will become a successful operation, you get it. So our success, our interest in this application is what? The faulty goods or the problematic unit, you get it. So now one is asking why 1 minus P. I think the person wasn't here. So 1 minus P, because we know that all probabilities are added up to what? 1. And you are giving the probability of success to be P. We don't know they didn't mention the probability. They said 10% of the discrete unit will have problems, but they didn't mention the probability that the probability of the unit not having problems. I don't know if you get me. So if you know the probability of the defective unit, what will be the probability of what? The good or acceptable unit. And we know that all probabilities are added up to be 1. So if you know the probability of defective unit, you just subtract it from the number 1. So 1 minus P will give us what? The success of failure, that is the Q. So in this particular question, 1 minus 10% or 100 minus 10% will give us what? 90%. That one will be a probability of the failure. So any question before? Okay, he said it's okay now. Okay, so let's make progress. All right, let's make progress. Now, the binomial distribution applies to this situation because the following condition exists. There are only 2 possible outcomes when a unit is installed. So let's say the unit were fan, security unit. I don't know if I should use CCTV camera. Yes. So when they installed the first product, after installing the unit, so you don't know the quantities. They are saying 300 or something like that. So it's either good or what? After installing it, it can be what? Good or bad. Finding a defective unit. Look at this point. Finding a defective unit will be considered as what? A success. Why is it that there is a defective in this question? The word defective is here, but we are considering it to be what? A success. I said the success is our portion of interest. And now the interest in this application is to figure out the unit with faulty, like the unit with what? Problems. You get it? So the defective unit will be what? The success, not the good one. A success occurs when we observe the outcome of interest. Yes. So a success occurs when we observe the outcome of interest. And the outcome of interest is what? Looking at what? The faulty unit. You get it? Each unit is designed and made in the same way. The outcome of security unit, good or defective, is independent of whether preceding unit was good or defective unit. Here they are talking about what? Mutually exclusive. So after installing camera 2, the results, whether it was good or bad, it has nothing to do with what? The camera 3 that will be installed. And the probability of a defective unit P is 0.10, remains constant from unit to unit, whereas the probability of a good unit Q is equal to 1 minus P, which will be 0.90 or 90%, remains constant from unit to unit. All right. I hope we can make progress. I've explained this one already. Now, the same application our brother read for us. They are saying to determine the likely cause of defects, design or manufacturing, the quality assurance group at Household developed a plan for dismantling a random sample of what for security units each week. So to determine the likely cause of the defect, they want to know the likely, you get it, the likely cause of defect. What causes that defect? Design or manufacturing. So the quality assurance decided, get it, to develop a plan for dismantling a random sample of 4 units, security unit each week. So the sample size will be 4/300. That will be 1.33% relative to the size of the population. Now we are saying let the number of defective units be random variable of interest. So the random variable, they are saying 4 security units each week. So let the number of defective units be the variable of what? Interest. You get it? So X is equal to what? So 4 security units, and they are looking for what? So after dismantling, performing this sample or this trial, you get it? They are looking for what? The defective unit. And they perform 4 trials. So if they are looking for the random variables, I told you that for the discrete random variables, when you are starting with it, just start with the number 0. You get it? Because there can be a chance of not getting what you are looking for. So here they are looking for defective units. So they can be case that after performing all the 4 trials, they will get what? 0 defective. After performing all the 4 trials, they will get only 1 defective, and the 3 others will be good. After performing the second one, like after performing all the 4 trials, they will get what? 2 defectives, and there will be 2 good units. After performing all the trials, there will be what? 3 defective units and only 1 acceptable or good unit. And after performing all the trials, they'll get all of them to be what? A defective unit. You get it? So what is the probability that there will be 0, 1, 2, 3, or 4 defectives among the sample? All right. So are you okay with it? Can I move on to the workings? Are you okay with the explanations?
Yes, please.
Okay. So they are saying that let G represent unit that is good or not defective. You get it? Well, let me switch to the whiteboard. So they are saying that let G be goose that are good and coming. Yes, G represents unit which is good. G represents unit which is good. That's good and coming. So let's G here. Unit is good or not defective. So if G is a probability, if G is good unit, then the probability of G will be what? What is the probability of G? Who can tell me?
0.9.
Good, because they are saying that the probability of what? The defective unit is 10%, that is 0.1. So when you are looking for the probability that unit is good, then it will be 1 minus P. In other words, 1 minus the 10% given. That would be what? 90% or 0.9. So 0.9. All right. Now the question is asking us to find the probability that, what is the probability that? Come on. What is the probability that there will be, what's the probability that there will be zero? What's the probability that there will be 0, 1, 2, or 3 defective? You get it? So what's the probability that there will be what? 0 defectives? Because the defective here becomes our success. Though it's a defective unit. You get it? But we consider it to be a success in this particular application because that is our interest of outcome. Because we are looking for the defective unit. We are not interested in the not defective or good unit. So the good unit here becomes our failure in this particular application. Listen carefully. So you being able to figure out your success should be important to you or must be important to you. You get it? Because at times it confuses because you will say that unit is good there, then that one is what? Like the success. No, they only mentioned the defective unit. The percentage was for what? Defective. So the defective in the application becomes our success. You get it? So our probability of defective. So let D equals to what? Unit is what? Defective. And probability of what? Defective unit, they said is what? 10%. 0.1. Good. So they are asking us to solve or find the probability that there will be 0, 1, 2, 3, or 4 defective among the sample. So after performing the sample, what will be the probability that there will be 0? What will be the probability that there will be 0 what? There will be 0. So X here is what? X is 0. Because what will be the probability that there will be a 0 defective? Do you get it? Do you understand what you are doing? Do you really understand what you are doing? Hello?
Yeah.
Okay, so probability that there will be what? A 0 defective. So S is equal to 0 defective. Do you all understand before I continue? Because this one, we have to understand together. Do we all understand?
So
Yes.
far, so good.
All right.
So far, so good. Yeah.
Let's make progress. Okay. So we are looking for the probability that among the sampling, you get it. They did 4 sampling. So what is the probability that among that 4 sampling, dismantling date, there will be a 0 defective unit? You get it. After performing all the 4 trials, you get none of them to be what? Defective. That means all of them are working. So what is the probability? What will be the probability that 0 of the unit will be what? Defective? Now, we know that probability of G represent what? Unit that is not what? Defective. Do you get it? So is the probability
Yes.
is the probability of good times probability of good times. Oh, it is ending 10 minutes time. Who said it will not end? Times probability of
The host, you are still the host.
really.
Yeah.
Let me change it. Oh, I changed it to preview. Let me make and so time remaining is 9. Okay, let's continue. If it ends, you will join again. All right. Then multiply by the probability of good as well. Now let me explain this one again. The question was like, we should find a probability that there will be a 0 defective, meaning after performing the trials, all the 4 trials, you get 0 defective unit, meaning there will be 0 defective unit. You get it? You have no defective unit. So it's the probability of good times probability of good times probability of good times probability of good, meaning all the 4 sampling or all the 4 trials will be what? Good, because they are saying 0 defective. If it is 0 defective, then it is what? Good. And probability, we multiply it. And we know that probability of good unit is what? 0.9. So just multiply 0.9 4 times. So this one, it is 0.9 times 0.9 times 0.9 times 0.9. You get it? And that one will be 0.9 raised to the power 4, right?
Yes.
Raised to the power 4. So what is 0.9 raised to the power 4?
0.6561.
6561. Okay, so that's the answer for the first one here. What is the probability that there will be 0 defective? So 0 defective, this is the probability. So the probability is getting closer to 1, which means it is likely to occur that after performing all the 4 trials, 60% or something like that, yes, we will have what? 0 defective, or yes, you get it to be what? A good or acceptable unit. So you just, if they mention 0 defective, and mind you, I said when you are writing the discrete random variables, start with the number 0, because there will be a situation where we can get none. Like we said, we are looking for a defective, but we can get a situation whereby you get all of the product or the unit to be what? Good. You not get a defective. So you always start your random variables or discrete random variables with a 0. And they're asking us what is the probability that there will be a 0 defectives among the sample. So this is the 0 defective. And we know that they perform what? 4 trials. So it is 1, 2, 3, 4. And we know that if it is 0 defective, the other outcome is what? Good defective. And we know that the good defective was represented as what? 0. Was the probability of good defective. In this case, is the probability of our failure, because our success, our outcome of interest is what? Defective, which is was the 0.1. That becomes our success. So our probability of failure becomes the 0.9, which is the probability of good product. Do you get it? So if they are saying we should find a probability that there will be a 0 defective, you just take the good and multiply it by and raise it to the number 4, because it will be good times good times good times good. You have none to be what? Bad or defective. So it will be 0.9 times 0.9 times 0.9 times 0.9, which will be equal to at 0.9 raised to the power 4. All right. So let's move on to the probability that there will be what?
One effect.
One defective. Good. We started with there will be what? 0 defective. Now let's start. Let's also work for the probability that there will be what? 1 defective, 2 defective, 3 defectives, or 4 defectives. Okay, so this was the question. So that's the first one. So let's move on to the probability that there will be what? 1 defective. So S is equal to 1 defective. So who can give me a clue to this one? Probability that there will be 1 defective. They are performing 4 trials, and they are saying that for sampling, and among the sampling, there will be 1 defective in it. So if the thing is 4 and there will be 1 defective, meaning the rest of the 3 will be what? Good, and 1 will be what? Defective, making what? 4. Do you get? Okay. See and talk. Roger, I'm listening. Hello, your hand is up. I'm listening. Your hand is up. Okay. You don't have a question. Okay, thank you. So the probability that there will be a 1 defective. The first one was what? 0 defective. That one we know all of the 4 will be what? Good. But now they are saying that every 1 sampling there will be what? 1 defective. You get it? So three will be good and 1 will be defective. Good. 3 will be good and 1 will be defective. So it's what? Probability that. All right. So probability that there will be what? Good. Okay. So probability of good times good times good. Then the last one will be what? Defective. This is the first sampling. Now the second one, they are performing for sampling. You get it? So the second one too, the probabilities can be, it will be good. The first sampling, the 4th unit was defective. So this one, the 3rd unit will be 1. We are assuming the 3rd unit will be defective. and the fourth we need to be what? Good. Right? Plus probability that there will be good. So if the first one, the last one was a defective, in the second sampling, the third one was defective. This time around, the second one will be what? Defective. And the third will be good, fourth will be good. You get it. Then the last one, the first one will be what? Defective. The next one will be good, good, good. All right. So do you understand? Do you understand? Do you understand this part?
Yes, please.
Okay, thank you.
Yes, please.
Okay, see, I got you. Don't worry. You can type, I'll see. Okay, so let's make progress. So probability that first one can be good, 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 defective, good, 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 defective, good. The third one will be good, defective, good, good. The last one will be defective, good, good, good. Now we know that probability of good is what? 0.9, right?
Yes, please.
And multiplying the probability that there'll be a good defective. So the defective probability is what? 0.1, right?
Yeah.
And we did this for how many times? We did this for 4 times, right? So in all of them, in every sampling, you get 4, like 1 defective, you get it, and the rest of them, that is 3, will be what? Good. So we established that the first one, there will be good, 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 defective. The second one, good, good, defective, good. The third one, good, defective, good, good. The fourth one, it will be what? Defective, good, good, good. So it was last year, it became third in the second. It became second in the third. It became first. The defective became first in the first one. So we are saying that probability of good is 3 times. So you square this one, 9 raised to the power 3,
3.
and 10 raised to the power what? 1, 0.1 raised to the power 1. Then we did that for 4 times. That's why I'm multiplying it by 4. But with the first one, we didn't multiply it by 4 because all of them were good. That's why we see good, 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 good. But the reason why we are multiplying 4 here is that if every sample we perform, like every sample we do, we get one of them to go as a defective. And we perform how many? Like the sample size of, yes, it was 4. So we multiply it by 4. So what would be the answer?
Zero point 9
Is it? Come again, please.
0.2916.
0.2916.
16, yeah.
All right. Are you all getting the same thing?
Yes, please.
All right. I'm coming. Okay. So we are now moving to a probability that there will be 2
2.
defective. All right. So that one will be probability that there will be good, good, defective and what? Defective. You get it. So this one, we are not going to worry ourselves, right, this things. Write all of them. Now we know that we are performing 4 samples and we are saying 2 of them will be defective, 2 of them will be good. We know the probability of what? Good defective. Good unit. That one is what? 0.9, right?
Yes, please.
Multiplying the probability that there will be what? Defective unit. That one too is what? 0.1. Then we know that they are saying there will be 2 defective. So if 2 defective is 0.1 raised to the power
2.
Raised to the power raised to the power 2. Then 0.9 will be what? 0.9 will also raise to the power 2 as well, because the thing is 4. Okay. Is there any question? So all right.
No question.
So this one too, when you have to do this one, you have to write it. So let me write this one. So this one 2 times probability that there will be, let me clean this one. So the first sampling, the third and fourth was what? The defective unit. So this time around, the good multiplying defective, and what? Good. So you do this, so you get what? To the end. So I think this one I'm going to get 6 ways. You get it. So this one I'll leave you to do the 2, 3, and what? 4. Do you get it?
Okay.
So let's come back to the slide. Now we are saying, can you see the slide? Can you see the screen?
Yes, yes, please.
Okay. So we are saying that when the results is good, the number of defective is 0, and the result is good, the number of ways is going to be 1. When you have 1 unit to be defective, the number of ways is going to be 4.
Oh.
When you have 2 units to be defective, the number of ways is going to be 6. So you will be doing this till you get to 6 ways. That's why I stopped. I wanted you to do it on your own because I've given you the clue. If the number of defective units are 3, you get to 4 ways. And if you have all the sampling to be 4 defective, all of them to be defective. In other words, if you have your number of defective to be 4 units, your number of ways is 1. So we going through all that like tedious work. We doing this till we get the 6 ways, doing the number of defective for 3 to be 4 ways, and it to be what? Like I don't know the exact word to use to get it. To be plenty, you get it. So we have a simple and a shorter method there, and we call it binomial coefficient. Call it binomial coefficient. So we are saying, looking at the slide, we are saying that a more efficient method exists for counting the number of ways binomial events exist, and we call it binomial coefficient. Yes. So counting rule for combinations. A combination is the number of ways of picking S on ordered outcomes. S on ordered outcomes from n possibilities. So this is the function Cn S is equal to n factorial over x factorial multiplying n minus x all at factorial. Do Do you get it? We call it binomial coefficient. And when you are using this, I can teach you a shorter method on the calculator. So you are going to use CNS. So that one, it will be N, then C will come, then you type your X. Now this combination sign, the C sign is on the calculator. So when you press shift plus the division sign, you get the C there. You get it. So if you can try it, you will see shift plus the division sign. I mean the key beneath or below the AC. So shift plus division sign, you get your combination sign. So you type your N, your value for N here. Let's say if it was 5 here, your X value 2 will come. I don't know, let's say 2. When you use this long method, when you use this short method on the calculator, the answer will be the same. Now, someone will ask, I didn't do relative mass in SHS, so I don't know the factorial something. Let me teach you a simple. Now, the factorial means, let's say 3 factorial. It means 3 times all the numbers below it. So 3 times 2 times what? 1. 4 factorial becomes what? 4 times 3 times 2 times what? 1. 5 factorial becomes 5 times 4 times 3 times 2 times 1. Do you get it? And we are saying that 0 factorial is definition is defined to be what? 1. Is definition by 1. So when you see 0 factorial, just write 1, because when you punch factorial on the calculator, now factorial on the calculator, you press shift and the key below the mode or setup key. On the key, you see X raised to power -1. So when you press shift plus the key S raised to power 1, you are going to get your exclamation sign. That's the factorial. So when you type 0 factorial, you are going to get 1 on the calculator. So you are saying that by definition, 0 factorial is 1. For me, I cannot prove, but that's what the mathematicians are saying, that 0 factorial is 1. So when you are solving a question and you see X to be 0, consider it to be what? 1. Right? Now, where N factorial is what? And that's what I've explained. So 6 factorial is what? 6 times 5 times 4 times 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 3 factorial 3 times 2 times 1. So the exact number mentioned, multiplying the numbers below it. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And they are saying 0 factorial by definition is what? 1. And 1 factorial 2 is 1, because it will be 1 times 1. So 1 factorial is 1, 0 factorial is 1. So that's what they are writing here. 0 factorial is 1 by definition. See, a number of combination of X on objects selected from n objects. It's also called the binomial coefficient. We have explained everything here. Let's make progress. Right. So we are saying, using the binomial coefficient, the number of ways that it can occur. Remember, we were doing something, probability that, let me show you here. We were doing something like this. We are about to go through all the 6 like possible outcomes. It will be something else. You get it? So simple method, we are saying that probability of X being 2 or 2 defectives. We just use that simple method. So there's the formula was what? N factorial all over hat x factorial multiplying n minus s factorial. And in this particular phenomenon here, we are looking for the number of ways. The number of ways is what we are looking. So the x is 2, n is what? 4.
4.
So it will be what? 4 factorial 2 factorial multiplying 4 minus 2 what? Factorial. When you punch this on the calculator, you have what? 6 ways.
6.
Yes, so 6 ways. Your ways will be what? 6. You get it? Now let's use the one on the calculator. I said it will be n, c.
Combination.
Now n is what? 4.
4.
Combination. S is what?
2.
2. So you press 4 on the calculator. Combination is shift plus division sign. Then 2. That one, so you see that the answer will be what? 6.
6.
So use that formula. Use this short one on the calculator. Have the same result. You get it?
Yeah.
Right. So I hope all of you are good with it.
Yes, please.
All right. The rest, are you okay?
Yes.
Oh, okay. So after getting the number of ways, we are now going to find the what? Probability of that. You get it? So the probability of S to be defective, S to be 2 defective, is the number of ways, that is 6, multiplying the number of good and number of what? Bad. So the number of good is the what? 0.9. It will be what? 2, because 2 were defective and the total is 4. If 2 are defective, then 2 will be what? Good or acceptable. So we raise to the power 2, multiplying the probability that multiplying the probability of what? Defective, 0.1. That one too, they said 2, because 2 defectives, 2 good. That one will be your answer. So calculate this one and tell me.
This is
0.048.
4.
Okay, so this is the probability that there will be a true defective what? Unit. Now they are saying in the slide that what is the probability? What's the probability that there will be 3 defectives, and what's the probability that there will be 4 defectives? Okay, let me do the third, and you do the fourth, right?
Okay.
Yeah. So probability that x will be 3. So we first of all look for your search for what? Your number of ways. So that one too is n factorial. N is still 4. So 4 factorial. S has changed from 2 to 3. So 3 factorial. Into bracket 4 minus 3 factorial. You get it? So what will be the answer? Just punch it straight. You get a number of ways.
Four.
Okay, so
4 ways.
4 ways, right?
Yes, please.
So you then multiply the 4 ways by, we are saying that how to be the probability that there will be 3 defectives. So if it is 3 defectives, then it means only 1 unit is what?
Good.
Good. So 0.9 times 3 defectives, 0.10, because they are 3, raised to the power 3. What will be the answer? So that's the probability that the answer will be the probability that 3 units to be what? Defective. So 4 by so the answer is what? 0.0.
0.00036.
Ah, 0036. Yeah.
Okay. So you can do the 4th one yourself. So that one, the 3 here will change to 4 factorial. Then 4 minus 4 factorial. You are getting 1 way. So to be 1 times, all of them will be defective. So this one will not count. So it will be 1 times 0.1 raised to the power 4. The answer will give you the probability that 4 units will be what? Defective. And we are also saying that, let's move to the slide. We are saying that there is more shorter method in finding the probabilities. Okay, so let's finish with this one and end the lectures. Okay, so we are saying that probability, we are having a certain function formula there. We call it binomial distribution formula. So that one, you see that in the binomial coefficients, we have to solve for the number of ways before we multiply it with the probabilities of good and effective. But we have a more simple method, a simpler method there. That one is binomial distribution formula. So this is the method formula. P of x is equal to n factorial over what? X factorial, n minus x factorial, multiplying probability of success raised by x, multiplying probability of failure raised to the power n minus negative x. So P of x is the probability of x successes in n trials with probability of success P on each trial. So P here is the probability of success. Q here is probability of what? Failure. And we all know n to be 4. That's the random size or the number of trials. N minus x is becomes number of failures. You get it? X is number of successes. You get it? Q is the probability of failure, and 0 factorial, we know that is 1 by definition. So they are giving us, they've given us this formula, and also we are having this example here. So when you flip a coin 4 times, let S be the number of heads. So the number of heads are saying we don't know the number of heads. So you flip the coin 4 times. So here the sample space or random sample size becomes 4. But when you are listing them, you start with 0 because it's possible that you have no head. You will have 1 head, 2 heads, 3 heads, or what? 4 heads, because you flipped it for 4 times. You get it? So you see that you have no head, have 1 head, have 2 heads, have 3 heads, or what? 4 heads, right? So the formula is not difficult. So it is probability of x is equal to the formula that we used to know, n factorial over x factorial, into bracket n minus x factorial, multiplying what we were doing here, p factorial raised to the power x multiplying, let me use dots, multiplying q is what? Failure, n minus x. And this method will work for you like a magic. This formula will work for you. Okay, the same formula too, you can use this p of x. Then with the binomial coefficient, you use what I taught you on the calculator. So it's NCX multiplying p of x multiplying probability of failure n minus what? X. This one to work for you is the same as what? This. Right. So we are giving an example. It's left with what? 6 minutes. Let's join and let's solve the example. All right. Okay, let's make progress. So you know the formula to be this. So this is the example we have. N to be 4, P to be what? P is the what? Probability of success. So if we are looking for Q, which is probability of failure, is 1 minus P, which will give us what? Q. And they give us P to be 0.5. So 1 minus 0.5 will give us what? 0.5. That's why we are seeing 0.5 here as well, 0.5. Okay. Okay, so let's use the formula here to start. So P of x is equal to what? N factorial x factorial all over n minus x factorial multiplying u raised to the power x multiplying q minus x. So this one is just what? A substitution. So we are saying you should do x is equal to 0, 1, 2, 3, and 4. So let's substitute them. So we first of all pick x to be 0. We know n is what? 4. X is what? X factorial. X factorial. So x is what? 0. 0 factorial. So this one is 4 factorial. Multiplying 4 minus 0 factorial. Hope you understand what you are doing.
Yes, please. Yes, please.
So the probability of success, which is P, is 0.5, is here. So 0.5 raised to the power x, x is 0. Multiplying Q, Q to 0.5. Then n is what? 4 minus x to be what? 0. Okay, fast. Just point this one on the calculator. Punch it.
0.0625. 0625.
Come again,
0625.
I know that.
Is it in here? Is 0.0. The one saying it in here, are you having the same answer now?
Yes, please. I know that.
0.062 5.
5.
So do that for probability that x is 1. So just change s to what? 1. So it's just a substitution, something. So it will be p of 1 is equal to 4 factorial all over x has changed from 0 to 1, so 1 factorial multiplying 4 minus 1 factorial times p 0.5 raised to the power x. S has changed from 0 to 1 times p q is 0.5 raised to the power at n is 4 minus x. X is what? 1. What will be the answer for this one as well? Hmm?
0.25.
0.25. So that's the probability that x is equal to 1. Okay, let's move on to the probability that x is equal to 2. So 4 factorial over 2 factorial multiplying 4 minus 2. This mouse factorial multiplying. Sorry, I'm using mouse. So 0.5. This time around, the s is now 2 multiplying 0.5 4 minus 2 plus n minus x. Are you following it?
Yes, please.
What about the rest? Ulan, are you okay? Georgina, are you okay?
Yes, you are following, you are observing.
Okay, so give me the answer that give me the answer for s is equal to 2.
0.375.
So let's move on to p is probability that s is equal to 3. So just substitution, okay. Multiplying 0. Probability of success is still 0.5. X has changed to 3. Multiplying 0.5 to the probability of failure raised upon n minus x. That's 4 minus 3 now. Someone should do it apart from the one giving us the answer. It seems only him is providing the answer.
Notice that some of us are not with calculators. That's why it's like most of us are not participating in the calculation of it.
Okay, but
You get me?
will you be able to punch the exclamation sign? I mean the factorial on the calculator.
Yeah.
No, some
Okay. So to get the exclamation sign or the factorial is just shift plus the divisions the key right under the mode or setup sign, setup key. On the key, you will see x raised to the power -1. So when you press shift plus that key, you will get that exclamation sign. Okay, so probability that s is equal to 3. What was the answer?
0.25.
0.25. Okay, let's move on to probability that s is equal to 4. 0.5 raised to the power 4 multiplying 0.5 here. The probability of failure raised upon n minus s. N is 4 minus x. X is now at 4. So what will be the answer for this one as well?
0.0625.
So you can see that the answers are related because the number of ways and those that were also related. You get so 0.625. We got it here as well. 0.25. This was here. We get it. Good. So this is how we compute for. We use the binomial distribution formula. So it's not anything long. Now let's use one of them to confirm my formula I brought. So probability of, let's go for the third one. P is equal to 3. S is equal to 3. So I said it is n combination x multiplying the probability of success raised to the power x multiplying probability of failure raised to the power n minus 1 x. So you bring the n is 4, combination 3, x is 3, multiplying 0.5, multiplying n is 4 minus x, s is what, 2. Okay, when you press 4 shift, you are looking for C on the calculator. So the C on the calculator is shift plus the division sign. Shift plus the division sign. To give this.
What have you written?
Jet.
Did you get the 4 minus 2?
Z.
If written 4 minus 2.
Okay, 4 minus 3. Sorry. Thank you. Thanks for the question. So shift plus division sign will give you the combination sign here. So you press for shift plus division sign will give you the C, then bring the 3. That will give you 4. You multiply with 0.5 raised to the power x. X is 3.
Yeah.
So 0.5 raised to the power 3 times 0.5 raised to the power 4 minus 3. And who is giving me the answer?
0.25.
0.25.
No, I'm talking about
The final answer what?
Yes, please.
So this one will give you 0.06.
0625.
25. And when you multiply it by 4, you are getting 0.25. So you see that it's not different from what I'm having here. It's the same. So you can use this formula. You can use the long one in the slide as well. You get it? So the important thing is to identify your n in the question. So they will not give it to you straight like this. It will be in application form. So you have to figure your n, sample size, your p, probability of success, your q, probability of failure, and your x is your discrete random variables. Then you can substitute it in the what equation. Now there can be a question when they will ask you, what is the probability that x will at 2 and 3? 2 and 3. So you work for 2, that's 0.375. You work for 0.25, which is 3. You add them. You can also be asked, what's the probability that x will do at greater than or equal to 3? So that one you do 3 and 4 alone. And if you are asked, what's the probability that s is greater than 3? If it is greater than 3, 4 or more. So you do 4 only. If you are asked, what's the probability that x will be what? Less than 4. Now you do 0, 1, 2, 3. Less than or equal to 3. You do 0, 1, 2, and 3 itself. So at times, listening to the question is dynamic. Probabilities It depends on how you grab the question, right? So any question for me here? Any question for me here? So you can use the same thing to solve for what we were doing, this one. So with this one, your n will be coming. With this particular question, your n will be what? 4. That's in the first time. X, you choose either 2 or something. Now, we know that P will be what? Probability of success. That will be 0.1. Then your Q will be probability of failure. In other words, goods that are not defective. 0.90. N is what? 4. Your X is, it was 0, 1, 2, 3. You have everything here. So you can try this on your own. Substitute it, do everything. You get the probabilities that you were doing it long. So you get it once when you use what? The binomial distribution formula, this formula here, right? Okay. So I think we can use the graph to this one, isn't it? You can use the decision tree to see this one. Let's keep this one. So the experiment can be described as a sequence of 3 identical trials. 1 trial for each of the 3 customers who will enter the store. So that one was for this one. 2 outcomes: the customer makes a purchase, success, or the customer does not make a purchase. Failure are possible for each. So this one was talking about a customer. If on the basis of past experience, the store manager of ShopRite at Accra Mall estimates that the probability of a customer making a purchase when he or she entered the store is 30%, 0.3. What's the probability that the 2 of the next 3 customers will make a purchase? So this one, the success was what? Those who purchase the product. So the one who make a purchase, that one becomes our success. So they are saying that the customer who makes a purchase is success. The customer who doesn't make a purchase is what? Failure. Are possible for each trial. The probability that the customer will make a purchase is what? 30%, 0.3. And what is the probability of your what? Failure? Is 1 minus 0.3. That will give you a 70%, 0.7. Is assumed to be the same for all customers. So the purchase decision for each customer is independent of the decisions of the next customers. And what will be your X? Your X is here. What is the probability that 2, the word 2 becomes your X? S is equal to what? 2. Of the next 3 customers will make a purchase. So your S is 2, N is what? 3. Because the number of customers was the total number of customers who enter the store will be 3. Then yes, logic. I'll send the recordings. Okay. You have your probability of success 0.3 raised to power x2 times probability of failure 1 minus the probability of success. That will give you 0.7 raised to power n minus x. N is 3, s is 2. Minus will give you 1. The difference will give you 1. You solve for it. You use this formula I brought, the combination one, that one I taught you, or the general binomial distribution formula we know. You get the same answer. Okay. All right, so let's end the video here. Definitely, it's tomorrow. I'll continue with the binomial distribution here. The example here. I want us to tackle questions here because when you are given a question and you are told greater than at least 3 students are majoring in finance. Let's say greater than, at least is what greater than or equal to. So greater than means 3 or above. And it was 3 out of 10. So you cannot do for 1, cannot do for 3 or above. 4, 5, 6, 7, and 8. You get it? 9, 10. So if you are given 300 students or population to be 200, and you are told that what's the probability that at least 3 of those 200 students who are majoring in finance cannot do for 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to 200. No. So if it was at least 3, it means greater than or equal to 3. You turn the thing, you solve for probability that S is what? Less than or equal to what? 2. Then after everything, you subtract it from the number 1. That will give you the probability that you are looking for, because you are saying all probabilities are added up or are summed up to be 1. So you find the less than or equal to for the number below the number that was mentioned in the question. You subtract it from the number 1. That will give you what you are looking for. Okay. Then we move on to the pi zone. All right. So let's end here. Let's end here. If you have any question, kindly bring it up. As God willing, tomorrow I'll record a binomial distribution here in the example that follows, and I will meet you another time for the pi zone. Okay, the next time I'll meet you, you will do the pi zone together with the example here, and also do the hypergeometric. Then you bring probability distribution to an end. The first part. We now move on to normal and standard normal distribution, right? And it keeps on going, right? So any question before we end the meeting?
Hello.